So let's start with terminology again. We often refer to studies where each condition is different participants as a between subjects design. However, you'll also sometimes see it referred to as an independent subjects design. And both of these kind of have an intuitive meaning. Between subjects means that you're looking between each group, and that since you're comparing between groups, you're comparing between different people. Independent means that each group is independent from the other. In other words, different participants. A quick note, when we're talking about independent or between subject designs, we'll often refer to our total sample with a large N. So if we had 60 participants, we would put large N equals 60. If we were talking about a particular condition, we would often use a small n. So for example, if I had divided those 60 randomly and I had 21 people in one condition, 19 in the other, and 20 in the final condition, if I was referring to those specific conditions, I would say small n of 21 in condition 1, small n of 19 in condition 2, and small n of 20 in condition 3. So if you're reading a study and you see a large N, you know that's the total sample. And if you see a small n, you know that's a subset that was only exposed to one particular condition. So if we're looking at a between subjects design, we've created a design where we are manipulating or controlling an IV, or at least defining that independent variable into categories or groups, and each category or group is different people. So this is all about simply how you assign participants to your conditions of your IV. The advantage here is that participants are not exposed to more than one level of the IV, so the conditions have no effect on each other. In other words, they are independent. There is no carryover effects. So each individual who comes into your study is only exposed to one level. It makes it harder for them to know what your actual manipulations were about. It's harder for them to predict what the study was about because they don't have exposure to the other study conditions. So for example, if I was in that very simple example I keep using of the study guide study, and I was assigned to a condition where I didn't get a study guide, if the study is done well, I might not even know that some people got a study guide. All I know is that I didn't get one. If I got a study guide, I might not know that there were some that didn't get them, or that some were getting more than just the study guide. So that means that I basically am experiencing the study from a more limited viewpoint, which makes it harder for me to determine what the study is about. And this is a pretty big advantage because we do have to worry about participants trying to kind of guess our study. If we had done this exact same study in a within participants design, so every one of our participants is exposed to all three levels, they would actually very quickly figure out our study as they were exposed to a no study guide condition. Then the next time they have a study guide, and then the next time they have a study guide and study sessions. It'd be pretty easy to figure out, oh, you're actually looking at different levels of help and how it performs on tests. So a between subjects design, though, is where that doesn't have to be a worry. It's different people in each group, level or condition of our IV. So each one participant will only experience one level within our IV. And levels are conditions. The term is referring to each level of that IV. So if I have an IV with 3 levels, there are 3 conditions or 3 levels. And generally speaking, if at all possible, we want to use random assignment to determine who ends up in those particular conditions or levels. The disadvantages of between subjects designs, one of them is participants. You need more. So basically, we've been talking about various different rules of thumb with various studies, but broadly speaking, always more is better. About the minimum you would ever want to run in a between subject design would be maybe 10 participants per condition. And if you have 3 conditions, that means you need 30 participants. And that would, by the way, be not a very powerful design. It would have to be a fairly large effect for you to be able to statistically find it with that small of a sample. 20 would be better, still not great. You'd be able to find moderate effect sizes at that point. But again, if we have 20 participants with 3 levels, that means we need 60 people in our study. And generally speaking, if you're looking for more moderate or smaller effect sizes, you're probably going to need at least 30 people in a group. So again, a single IV with 3 levels, you're needing 90 people at this point. So there are still going to be individual differences. Random assignment does not assure equality. It's a damn good tool. It works most of the time. But we've already talked about the smaller the sample, the more likely those individual differences may cause effects. The random assignment works better with larger samples, another reason to have a lot of participants. But also, it is random. There are times where random assignment is going to basically put all of the A students in one group randomly. In other words, it doesn't assure equality. That's why a lot of more complex, more time-consuming, and more expensive studies often will use random assignment, but then have a pretest to make sure random assignment worked. So generally speaking, one of the big disadvantages of between subjects design is because we're using random assignment to try to get rid of the noise of individual differences. And it's a great tool, but it's not a perfect tool. And that we need a lot of participants across these conditions, it tends to have lower statistical power. Statistics need to eliminate those individual differences, even though we used random assignment. In other words, they're still there. They're just hopefully equal across conditions, but they're still creating some noise. So we're having to include that in our estimates of total variance. So in other words, all statistics examine the effect of the IV divided by total variance. And if you're using a between subjects design, part of the mathematical equation at the bottom of that equation, total variance, includes that there is still going to be some noise from individual differences. Not as much as if we didn't use random assignment, but it's still there. And that noise is going to be at the bottom of the equation, which means that it's going to be what we divide our effect size by. And if the larger the number that we divide our effect size by, that means that our obtained test statistic is going to end up being smaller. And the smaller it is, the less likely it is significant. So again, advantages of the between subjects design, we're going to talk about those a little bit more, but one of the big ones is that they are independent, that our groups are not having to worry about fatigue as much. They're not having to worry about how their exposure to each condition may impact their performance in the next condition, because they aren't experiencing anything but more than one condition. We're using random assignment to hopefully get rid of those individual differences. However, we need a large sample, we need more participants, and overall, we actually have a slightly lower statistically powerful design. So those individual differences can be extraneous. They can also be confounding. So again, random assignment to groups is our best tool, but we want to probably check that if we're really worried about it, because it doesn't always work perfectly. We may also want to think about matching the groups on extraneous variables. So if we know specifically that there are variables that we're worried about, in other words, we're worried about a particular group having more or less of a particular variable that might affect their DV, we may want to measure those individual differences. We may want to assign people conditions based on trying to equate those differences. If matching, however, we're no longer a between subject design. So if you decide you're going to use matching instead of random assignment, it's a either or choice. You either use random assignment or you use matching. We would use matching in situations where we're really less worried about individual differences across the board as we are on very specific individual differences that we can measure. In that case, we might want to say, for all we know, they may be individual differences that varied with our IV, but we don't think they're confounds. What we were worried about were these three, and therefore we measured them and we matched them. Now, notice that I said we're worried about three. It's pretty easy to match participants on a single variable, but rarely are we going to be matching on just one variable. And if we start trying to match people on multiple variables, it can become very difficult to truly match people across multiple conditions. And as a reminder, if we're using random assignment into groups with different people, we are still a between subject design. The second we decide to start controlling and matching, we're technically no longer a between subject design, and I'll talk about that in more detail later. Finally, we may just want to restrict some of the definitions of our sample itself. So, for example, if age differences are an issue, we're worried about young people versus old people, we may want to restrict our sample to only 18 to 21-year-old. So one of the other ways we can try to reduce extraneous or confounding variables when we find them is potentially remove them from our sample. Now, we're obviously going to be reducing external validity at this point. And remember, external and internal validity are always kind of a seesaw. If you're focused on an internal validity, I'm trying to get rid of these confounds, these extraneous variables. One of my tools is to try to get a very specific sample that would not vary on those extraneous or confounding variables. But if I do that, I'm also seriously reducing how well I can generalize this to people beyond that sample. So a dependent or within subject design, and again, let's talk about terminology. We often refer to these as within subject designs, but you'll sometimes see them referred to as dependent subject designs. So within, we're comparing within the same sample. In other words, all our subjects are being exposed to all levels of our IVs. And it's dependent. In other words, each participant is experiencing each condition, which means their responses to those conditions may be dependent on their previous exposures. So for instance, if I was actually doing a study where there were 3 conditions, 1, control, 2, I'm trying to induce prejudice, 3, I'm actually modeling prejudice. Well, if participants are going through that, when they hit the inducing prejudice or modeling prejudice conditions, they will have already experienced one of the other conditions that are involving trying to increase prejudice. Therefore, they've kind of been pre-framed to potentially already be affected. So in that case, if I'm worried about that dependency, I might not want a within subject design. So again, the biggest definition here is that one participant equals all levels or conditions. They're exposed to everything. There's no small n's here. There is big N. And big N, your participants, if you have 32 participants, there are 32 participants in level 1, 32 participants in level 2, 32 participants in level 3, and they're all the same. So the groups are equated. The differences between groups 1 mean and groups 2 mean is less likely to be due to individual differences. So the big advantage of this is it is a better tool in some ways than even random assignment, in that there is no question that there is no variance due to individual differences because it's the exact same people. And this is where the big difference statistically lies. If we are doing a dependent within subject design, we are going to use a different equation. It may be the same technical test, but instead of a t-test for between subjects, it'll be a t-test for within subjects. Instead of an ANOVA for between subjects, it'll be an ANOVA for within subjects. And the reason for this mathematical difference is that our calculations of statistics no longer need to try to estimate the noise of individual differences. In other words, we can simply remove that entire part of the bottom of the equation. So now we're just looking at total variance, not including an estimate of individual difference divided by the effect size, or dividing the effect size of the IV. So that means that always when if we ran the exact same statistical numbers through a between participants ANOVA and a within subjects ANOVA, the within subjects ANOVA would always be the more powerful design. It would always indicate a larger effect because the bottom of the equation no longer contains an estimate of individual differences. So the within subject advantages, we need less participants. So if our goal mark for a experimental design is 30 participants, if I have 3 conditions, instead of needing 90 people, I just need 30 people. We also don't have to really worry about individual differences anymore. The estimates are removed from the total variance because they are the same people, and therefore we have more statistical power. So we have more power because with 30 participants, we're effectively getting the same power as if we had 90 participants, because in both cases, we have 30 participants in every condition. And we no longer have to estimate individual differences, hoping that random assignment got rid of that problem. In fact, it's just gone. We don't even have it in the equation anymore. So remember that in between subject designs, individual differences can create extraneous variables, noise. There are ways to control for this, such as random assignment, but those methods are not perfect, and therefore we still have to estimate that noise as a part of our calculations. Within subjects do come with disadvantages. So first is order effects. Any possible change in the performance caused by participation in a previous treatment. So especially if I'm doing a study where each level is ramping up the level of intervention. In other words, if I'm starting from control, no intervention, to some intervention, to a lot of intervention, I'm no longer being able to compare a lot of intervention to some intervention as 2 completely different experiences, because the people that are in the condition that are getting a lot of intervention have already been in the condition where they got some intervention. So we can see kind of a possibility of a progressive error. Just the general experience of being in the study has affected and causes lingering over those effects, but are not specific to my IV manipulation. So we may also see practice effects, because if someone's exposed to all 3 levels, at the end of each exposure, they're going to do the DV, which means they're also going to get better at completing that DV. They're going to get more familiar with that dependent variable. They're going to get more familiar with the test. They're going to get more familiar with the outcome and how it's measured. We may also see the opposite of that, fatigue, where they just get tired of the study. They don't want to fill out the 30-item inventory of their anxiety for the third time in the row, and therefore they start getting sloppy with that. So one of the big things we have to worry about within subject designs is, by their very nature, we may be fatiguing our participants. They may be getting progressive errors. They may be getting better at the DV simply because of practice, or they may be getting worse with the DV because of fatigue. So with those order effects, what we often refer to them as far as terminology, is a carryover effect. That's a cause that's lingering from the previous treatments as it is specific to your IV manipulation. So again, if I had a between subjects design, different people in each condition, there would be no argument that if someone was in the most extreme treatment condition, that the effects that I found there were due to anything other than that specific treatment. If I was doing a within subject design, everyone exposed to every level, if I found a big increase with people in the extreme treatment condition, it might also be partly possible that it's because they were already exposed to the moderate treatment condition and that there's a carryover effect. In other words, they already got somewhat better and now they're even being given more. In other words, I can no longer make the claim that the extreme treatment condition on its own would actually have that effect in a regular real-world setting. In fact, what I'm really finding is that it just gave a continuing additional effect beyond the effect of the previous condition. So, for example, if we're doing a memory test, if you're learning a memory rehearsal strategy in the first condition of your IV, that may influence your ability to remember things in the second condition because, again, those carryover effects. Now, there are a few things we can do to try to get around this disadvantage, and we're going to talk about those, but we definitely want to be very conscious when we're doing a within subject design that by its very nature, it's going to be a longer study for those participants and may have to occur over multiple days or even multiple weeks as the participants are exposed to each condition. We also have to worry about contrast effects, so subjective perceptions of a subsequent IV level is affected by the previous treatment. So let's say I'm not actually even doing anything that's necessarily supposed to be looking at, for example, extreme intervention versus a moderate intervention. I also have to worry about the fact that because my participants are being exposed to every level of my IV, they may start doing additional contrasting or thinking about, okay, last week we did this week we're doing that. That's not something I have to worry about with a between subject design because you don't know the other IV levels. Here, you're learning about the study as you go through, and that may also therefore affect how you perform in that study. So after experiencing a very difficult level 1 of an IV, participants now have anxiety regarding the difficulty of the task in subsequent levels, and therefore may be underperforming when they shouldn't be simply because they're now anxious about what the next levels are going to contain. That would be an example of a contrasting effect. I'm comparing my current experience in the study to my past experiences in the same study.